Just getting this thing sorted out a little bit. Are you seeing a little picture of me top right hand corner, or are you seeing a picture with lots of you? Because I'd rather I would just is it just me? No picture? Top right hand corner. Is there a little square of me, or are you seeing like 8 people?
I see you.
Just me. Okay.
I can see you.
That's good. Let me see if I can. There, good. I can shrink that up as well. I think I must have knocked the thing over. Well, let me apologise first for giving you such short notice yesterday. I took a mental health day. I'm allowed to take 1 a quarter. My brother's birthday, he was 80 years old back in Scotland, and it was a big family get together. And I was on the phone, because of the time difference, I was a bit early. So I was on the phone to him, and I got very homesick. And so I decided to just have a day off and chill out. And so I did. I'm still homesick, but they don't pay me money to not be at school, so I have to do my job. So I'm a little bit distracted, even more so than I usually am. So your job is to keep me on the straight and narrow. So when I screw up, if I multiply something or whatever, you'll tell me that 2 should be a 12 or something. So keep your thought processes going. So we're going to start a new chapter today. It's called Introduction to Sampling. It's actually a very short chapter. I think there are 9 or 10 questions. And all the questions are mostly, here is something, and there's a list of 4 or 5 choices. So it's really vocabulary and getting us into sampling. Sampling's not a mystery because we've talked about it in all sorts of different times. So it's not new. We're just going to add some stuff to it. Now, let's talk about the first thing. We have a thing called the population. The population is essentially everyone we are interested in. And the population isn't necessarily everybody in the world. I might only be interested in the smoking habits of teenagers. So in that case, wouldn't the population only be teenagers in America, say, right? I might be interested in the voting habits of adults in Bremerton. Well, the population there would only be adults in Bremerton who can vote. So you wouldn't count me in that population, for instance, because I can't vote. So the population is everyone we're interested in. And normally in a population, we are very interested in 2 numbers in particular, mostly. And the 2 things that we are interested in is finding out what the mean is, right? And that's called mu, right? We'd like to know what the average age of, people in Bremerton are, right? Or we'd like to know the average amount of salary they make, or the average price of the house, or whatever it is, right? Mean of a population is very often very interesting. And the second thing is called the proportion. And we use the letter P. So if you ever see the letter P on its own, we mean it's a population proportion. So can you imagine that the population of interest is people who are going to vote Democrat in the governor's election, right? So the population might be adults who can vote in Washington state, and the proportion P is the percentage who would vote for the Democrat. So whenever you see mu, you know it's mean, but we've seen that earlier, haven't we? We're used to that. And P is going to be for proportion, right? So that was a question where 42% said yes, or 0.4 said yes. And then we have another guy, and he's always smaller, right? And he's called the sample. And the sample is everyone we asked. So we only asked 200 people in Bremerton what's their age. The sample there is the 200 people we asked. We only asked 4,000 people in America who they were going to vote for in the presidential election, right? In that case, the sample is who we asked. The sample doesn't include people we don't ask, right? And the sample obviously is much smaller because of that. Now, in a sample, we would very often calculate the mean, but when we do that, don't we call it X bar? And the proportion, we very often do that, right? We asked 200 people and, 0.12 said they were going to vote Democrat. We will use that symbol. I'll do a big version of it. And you say it out loud as p hat. Right? So p hat, if you ever see it, means you ask 200 people something and 42% said yes. P hat is 42%, but we almost always do it as a decimal. So it'll be 0.42 you would use. Right, some of that we've met, some of that's a little extra added on to what we've got. Are we comfortable with population and sample and means and proportion? Are we good? So far, so good. Now, we don't normally find this directly. If I write down sigma equals, don't I mean proportion? Don't I mean population? What is sigma? What does it represent?
Standard deviation.
Right, and it's the standard deviation of the population. When you do samples, there's different names that we use. We're a bit more relaxed about it. Couldn't you just call it S, standard deviation S, SD, S with a little subscript S, right? Anything that looks like these three guys means that it's a standard deviation of your sample. If they use sigma, they mean it's a standard deviation of your population. Now, this term, parameter, and this term, statistic, any number, any of these guys here, if the number comes from the population, we call those numbers parameters, or parameter, if it's singular. And if the numbers come from a sample, we call those numbers statistics, or statistic if there's one of them. In fact, the whole science is called statistics, gets its name from here. That's where it gets its name from. Any questions about that? Are we comfortable with the vocabulary? Okay, let's make up some pretend questions. Okay. Here is some information. Some of these numbers are parameters, and some of these numbers are statistics. Tell me any one of those that's a parameter.
Mu.
Okay. Check. Any others parameters?
Sigma.
And is there any others?
The P.
Yeah. And this guy is a statistic. And this guy is a statistic. So are you comfortable if someone gives you a story and they mention some of these, you'd be able to say this is a parameter, but that is a statistic? You can identify, because of the symbol that is used, which of the two basic versions they are. Isn't this a parameter which is the mean of the population? Isn't this a parameter that the population proportion is 0.3? And isn't this a parameter that says the population standard deviation is 9? This is a parameter that says the sample proportion is 0.7. And this is a statistic. The sample proportion is 0.7. And this is a statistic that says the standard deviation of the sample is 10. And we pretty much covered most of what you need to know to do the homework. So that homework at least. So am I on the right one? I think I am. Okay, so with a bit of luck, you are looking at chapter 9, Introduction to Sampling Distributions. Is that correct? Is that what you're saying? Okay. So it's one of those, here's a question, pick one of the 4 answers. So let's just randomly pick some. A polling organization sampled 1,000 adults and found that 71% of those who were sampled favored tougher penalties for convicted drunk driving. Right. Okay, and we have to, in each of these stories, there's one we just finished, explain whether the value in bold print, which I'm assuming it's hard to see, is that guy, is a parameter or a statistic. Is that 71% a parameter or a statistic?
Statistic.
And would you agree that it's, well, don't they mention a sample? There you go. Isn't that the key, right? It's a sample. Now, when I look at it, there are 2 statistics. It's that one or is that one? Is it a statistic because it's a population value, or is it a statistic because it's a sample value?
Sample.
Sample. In fact, aren't all statistics are sample values, and aren't all parameters population values, right? So you don't have a choice. It's not like sometimes it's one and then sometimes it's the other. Let's see me pick another one. A writer wants to know how many typing mistakes there are in a manuscript. So he hires a proofreader who reads the entire manuscript and finds 16 errors.
Number 3, parameter.
Isn't it the entire manuscript? So it's essentially the population was the whole book, right? The whole manuscript. Yeah. Oh, here's one of those fill in the missing word guys. A polling organization plans to sample 1,000 adults, and they want to estimate the proportion of Americans who think crime is a serious problem. In the context of this poll, explain the difference between a statistic and a parameter, and what is the parameter of interest to the polling organization, and what will be the statistic. So if I read this story, aren't they interested in the proportion of Americans who think crime is a serious problem, right? So the parameter of interest is the proportion of Americans who think crime is a serious problem. You happy about that from the choice? Right. Now, we can't ask all Americans, so the statistic will be the proportion of the 1,000 adults who said it was, and the statistic will estimate the unknown value of the parameter. Okay. Why do we do samples? This is kind of a rhetorical question. We'd rather do a census. Wouldn't we rather ask every American, do you think crime is a serious problem, right? Wouldn't we rather ask every single person in Bremerton who they're going to vote for, right? That would be we'd love to do that. But practically speaking, we very rarely ever do. So don't we do the next best thing? We get a sample. And in that sample, 42% are going to vote Democrat. Isn't that 42% the guy that we use to estimate what we think all of Bremerton would do? Now, it's not a perfect science. Would you agree that samples are never going to be exactly the same answer that you would have got if you asked everybody? But would you also agree that it's probably most of the time going to be pretty close to the right answer? Right? And that's what we do. We do samples to get an estimate of the real value. The sample is a statistic, right? That's what we call the number that you get, a statistic. It's a statistic that allows us to predict the parameter in the population. So maybe the statistic is the mean of our sample. Well, we're using it to get the population mean, or at least an estimate. Maybe our statistic is the proportion who are going to vote Democrat, P hat. That's our statistic. We're doing that to predict P, what the population, what everybody in Bremerton would do. And that's really the logic behind why anybody would do a sample. Next one, which one shall we do? Some stockholders want to know whether the mean salary for male employees in the company is higher than that for the females. The company allows them to access the salary information of all of their employees. And that happens to be 100 males and, just by sheer coincidence, 100 females. And the mean salaries are 58 for the males and 55 for the females. Could imagine that being realistic. Are the mean salaries in this set of information, in this story, are they statistics or are they parameters? Which of those two is it?
I want to say the parameters.
I would agree with you. Didn't they get everybody in the company? Right, they asked every single person. Now, if they'd said, well, our company's too big, so we randomly selected 20 guys and 20 girls, and this is the average, right? Because we have 100,000 people working for us, right? And that would have been a sample, right? That would have been a statistic. But they did ask everybody, so I would say it's a parameter. Now, based on the differences here, on the basis of these means, can the shareholders determine that the mean salary for males in this company is higher than the females? Yes. Would you agree that the males on average get paid 58 and the females get paid 55? Now, because that was everybody, there isn't any wiggle room, right? That's the final answer, right? That's what on average a guy gets paid. That's on average what a girl gets paid, right? So when you look at that, you can make of that what you will. You can interpret that differently, but it's still true that males get paid on average higher than females. And then you've got a sentence there. Now, let me ask a different question, which is much more fraught with danger. Does that prove that this company has a sexist payment policy? In other words, they deliberately pay males more than females. Now, the argument is, there are two arguments. Yes, it does, and no, it doesn't, right? And you could argue both of them. Right? You want to go one direction, you can say, of course it's obvious. How come the women are getting paid 3,000 less than the men? The men are getting all the better jobs. They're higher paid and the women's aren't. Could be true, right? You could argue it that way. You could argue it the other way. There is a lot of data out there right now that this is true. If you take the average hourly pay for a woman and the average hourly pay for a man, you can find good data on it. Men get paid more than women, typically on the hourly rate. And you might think, well, there you go, right? America's still sexist. They don't pay women the same for men. The counter argument says this. We agree that men get paid more than women. We can't argue with the facts, that's true. But there are reasons for it, and it's not just based on you're a woman, so I'm going to pay you $2 an hour less than the man doing the same job, because actually that's illegal now, isn't it? If two people are doing the exact same job and one's a woman and one's a man, and you pay the man $2 an hour more than a woman, that woman can sue that company and she'll probably win and make a lot of money out of it. So the companies don't do that. So you might say, well, how does that difference work now? Well, there are a couple of explanations for that. One is you have to look at the jobs. What jobs are high paying and what jobs are less high paying? Coal miners and lumberjacks and steel workers and people who work with heavy machinery probably get paid more than people who stock and serve in grocery stores. Would you agree? Aren't there a lot more men doing the first job and a lot more women doing the second kind of job? Do you see how the average would just be different because of jobs? If you look at different kinds of jobs like doctors and professional jobs, you might say, well, that shouldn't be that different. Well, in some respects, you're right, it's not. But women tend to have babies and men don't. And when women have babies, isn't it not unusual for them to maybe take a year off or a couple of years off while they're raising their young children and then return back to the work? Well, if you are in a job that has a career structure, like in business, won't that 5 years off your career change the level at which you'd be paid at? Because you've not had the extra 5 years that your husband has or your partner has had, right? And they've gone through the system. So even in professional jobs, they still find that men tend to get paid more than females. So yeah, you're right. Men get paid more than females. Is it because of sexist attitudes or is it some other reason? So always look at other reasons, even if you don't think the other reason's true, because it probably isn't. Maybe it is, and don't jump to it. Oh, here's a useless piece of information. Do you know that there are many more female community college lecturers than there are male? Did you know that? Does that mean community colleges are sexist? They only hire females more than males? Which is funny coming from a guy, I'm telling you that. No. Isn't that a choice that people like to do certain jobs and women like education, I suppose? I don't know. Whatever reason it is, more of them go into that field, right? And that will affect what you get paid. Okay, P hat and P. Remember I told you P hat is the sample proportion and P is the population proportion. So you're going to read the story and you're going to say, is this number coming from everybody in the population or is this number coming from the sample? Once you do that, you know if it's a P or a P hat. Yeah, you're right, could well be. Someone has some comments in there. Right, the proportion that smoke in a randomly selected sample. I don't need to read the rest. I already know the answer to you. Just the way the first few words came out. P or P hat?
P hat.
Came from a sample. C, the proportion that is left-handed in a sample. Oh, I'm starting again. P hat? I'm not even going to ask that question. Oh, X bar and mu. Isn't X bar a sample mean and mu a population mean? So you read the story and then you figure out whether or not it's a mu or an X bar. It's kind of hard, isn't it, to hide a sample? Because isn't somewhere in the story there going to be the word a sample of? So in question A, the mean hours of study per week was 18 hours for a sample of 40 students. Right. So I know that's a sample, right? I know that's an X bar, and an X bar from a sample is dot number 2. Can you see how quick your homework's going to be in this section? What about B? The university administrator determines that the mean age of all the students at the college is 20.5. I'm not quite sure how he determines. I hope he did it by asking their ages. And if I make that assumption, can we say it's new? It's in a random sample of 300 parents in a school, 127 supported a controversial new education program. The purpose of the survey was to estimate the proportion of all parents. So, what is the research question of interest? Well, if we go through this, we're interested in that, aren't we? Those who support this new educational program. So, which is the research question? What proportion of parents in the school district support the new program? Are you happy about that is the question. Then, what is the population parameter? Well, it's a population, so we want to know the proportion of all parents in the school district, almost got the wrong one, who support the new program. You agree? Population is all parents. What is the appropriate statistical notation symbol for this parameter? Which one of these dots would be the parameter for this story? I think I see the right number of fingers. P. P is population. Suppose the story was the AS 400. Wouldn't I be talking about that one? Now, what is the sample value? Now, we have to go back to the story here. 127 out of 300, agreed? And they want, I'm just going to my calculator now, 127 divided by 300, and I get 0.4233, and that's to 4 decimal places. Now, this is a sample statistic. Which one of these guys represents that number? Which one of those guys? I agree with you. Yes, you agree it's that one? Sample proportion. Question 7 is really just the same idea, a new story. Let's move on to question 8 then. Consider a situation in which the sample of 100 SAT scores is taken from the population of all people who took the test this year. Which would be more spread out? The sampling distribution of the sampling mean scores, or a histogram of 100 scores? If you only took 100 people and you put their scores and you made a little histogram, can you imagine how spread out that would be? If you asked everybody in America that did it, you got a lot more people. Would you expect it to be a lot more spread out? Yeah. And that one's a pretty standard one. All right, let's pick this one because it's the last question. Explain whether you would use p-hat, mu, x-bar, right, all the possible notations. So the mean of a sampling distribution of p-hat. when you get p-hat, aren't you trying to estimate p? I think that question would have been phrased a lot better if I'd phrased it that way. Would you agree that p-hat is estimating the p-value? One value from the sampling distribution. Okay, well, that's the same kind of question. So let's give you some intro to the next section, the final one. I think I've got it set up. Or maybe I don't. Thought I had. This one is going to be chapter 9 again. And it's sampling distributions for proportions. Oh, let's put it on so you can see me write it. What we're going to look at here is the theory behind why samples work. I know we have a gut feeling that they work, but we're going to actually be a little bit more rigorous than that. We're actually going to show you kind of the theory behind why they work. So I'm going to do a pretend story here, right? So let's suppose we're interested in the proportion of people who like Pepsi. So the proportion of people who like Pepsi. So if you say, do you like Pepsi? You say yes. If you say, nah, I don't like the flavor of Pepsi, you say no, right? You have to be a yes-no situation. Now, let's suppose that I take a sample of 100 people and I say to them, do you like Pepsi? And I'm going to call that sample N1. And the proportion of people who said, I like Pepsi was 0.7, just for argument's sake. And I'll call it P1 hat. If I had nothing else to work on, would it my best guess be about 70% of people like Pepsi? That's all I can do. Now, suppose I go and I choose another sample of 100 people. And I ask them the same question. Do you think I'm going to get 0.7 again? It's 100 different people from the last 100. Do you think it's still going to be 0.7? What's your gut feeling?
It could be 0.7. Again, depends on where you do it. If you do it in the same location, probably, you know, it's different people.
No, different people, but even with the same location, it's always a little bit different. Maybe, let's just say it's 0.65. Can that happen? Could be a little bit different. Does it mean I've done anything wrong? No. Because aren't you only picking a small group of people, and sometimes you get more Pepsi likers than the next time you do it, right? Or less Pepsi likers. And then you do it a third time, and you get the answer 0.71. And then they pretend, although some of them have actually physically done this, you pretend that you just keep doing it, right? Bill Gates gives you tons of money, so money is no option. You can do this till you get blue in the face. Can you imagine I could do lots and lots and lots of samples of 100 people all over America, right? Nice random samples. And I would get all sorts of numbers. And I'd get a lot of 0.7s, right? And a lot of 0.65s and so on and so forth. What they discovered was that if you take all of these samples and you make a histogram of them, the histogram has a shape that we have seen before. Do you recognize that shape? Normal distribution. So if you collect lots and lots of samples, this thing here is called a sampling distribution. And this sampling distribution will have the shape of a normal distribution. Right in the center, at the hill where the greatest number of answers congregate, would it seem reasonable that that's actually the population parameter P that you're trying to find? The percentage of Americans who like it. So in this normal distribution, the mean will be the same thing as P, right, which is the population proportion. Does that seem reasonable? That if you did lots and lots of samples and you put them in a histogram, wouldn't the middle where most of the numbers congregate, wouldn't that be the most likely place for the true answer of the population to live, right? Wouldn't it be weird if the right answer was over here? If you did it thousands and 1,000s and 100 samples each. Now, what is the standard deviation of this guy going to be called? Well, he's not actually called the standard deviation, although he is one. It's called the standard error. And it's written down as SE with a funny p hat. And it's the standard error of the sampling distribution, if you want to say it out loud. It's the standard error of the sampling distribution. But I want you to just think of it as the standard deviation of this, because that's essentially what it is. Now you might wonder what it is equal to, right? Because if I can find the standard deviation of this sampling distribution, don't I know pretty much everything I need to know about the population? Well, it's P, 1 minus P, okay, there. Oh, I just noticed something I need to do. If you bear with me for a second. I haven't got my question set up. Oh, override. Forgot to put my in. So I know the standard error, right? Which is essentially the standard deviation of this guy. So we're going to look at calculating the mean and the standard deviation, the standard error, given this fella here. So done it in space, where am I? No, shooting space. Sorry for this, I'm having issues with me window. I'm going to get this thing up and running. Otherwise, I won't be able to do it. Check this guy out. Okay, let's do one. Let's suppose, oh, we can do it for this class. Oh, yeah, let's do it for this class. I would like to know what percentage of you lot like Pepsi. And I'm going to use you lot to represent all of America. You didn't know that you were the same as the rest of America, right? So, darn it in space, it's being awkward today. Why can't I close the windows when I want to? Okay, never mind. I'll just do it the old-fashioned way. Right, you lot are going to vote, and you lot are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, I don't know where the others have gone, but we've got 15. We've got a second page. No. Do you know those little thumbs up things? If you like Pepsi, use a thumbs up thing, and I'm going to count these. 1. That's all that like Pepsi. 2. I like Pepsi, so I'm counting myself. 3. Last chance. Okay, we got our data. Oh, darn it in space. Don't know what it is with my computer today. Right. P hat 3 out of 15, which ends up being 0.2. So you want the mean? Basically, it's that guy. And you want the standard error. It's basically going to be P, 1 minus P, all over N. So you're going to go square root of 0.2 times 0.8 and divided by 15, and roughly to 2 decimal places, it's that. So the sampling distribution, this fella here.
Excuse me, real
Yes.
quick. How'd you get 0.8?
Oh, it's 1 minus P. So basically it's 0.2 times 1 take away 0.2, which is 0.8, all divided by N, which is 15. So 1 take away 0.2 is 0.8. Are we good? Any questions about that? So if I was using that, I could say, based on this very small sample, that it's 0.2, and then you go up by 0.1s. So I have a very rough idea. You won't really be able to go further than 0 on that side. But I have a rough idea what you lot think about Pepsi, but I can also make a prediction based on this sample, what I think everybody, if you lot are a fair representation at least, of America thinks of that. But we are only going to focus for the first part on calculating the mean and the standard deviation. And it's one more. I got a chat here. Do I need to answer anything? Oh, people taking names. Okay. Whoa, we're almost finished in time. Didn't realize that. Okay. Here is a couple of questions from the homework, and we'll start this tomorrow. In question 1, you're given a sample of 600 and you're told P is 0.5. So the mean in this case is 0.5 because the mean is P, and the standard deviation or standard error, all the other names, is going to be P 1 minus P over N. So that's going to be P, nothing 0.5, 1 minus P, which is that guy, over 600. If I go to my calculator, the square root of 0.5 times 1 minus 0.5, which is also 0.5, divided by 600. And the answer I get to, what did they want? 4 decimal places, is 0.0204. And that's essentially question 1A.
Professor,
Yes.
just to be safe, and I want to make sure I get this right, that should be
Uh-huh.
p hat, correct?
Oh,
Because
it's
you have it listed as
population.
p.
Yeah, you're going to use P. And if it's a sample, you're going to use P hat. So technically speaking, it should be P.
Okay.
But in the one I did, I called it P hat because I'm thinking to use a sample.
Okay.
Right. Yeah. 1B. Whoa. 2,400. And P is 0.5. Right. Well, the mean of the sampling distribution would still be 0.5. And its standard deviation, standard error, what you want to call it, is P 1 minus P over N. Oh, before I do this calculation, this is what you get when the sample is 600. What do you think the standard deviation would look like if you chose more people, like 2,400? Do you think you'd get a smaller or a bigger standard deviation?
Smaller.
Yeah. Nothing 0.5 times nothing 0.5 divided by 2,400 ends up being 0.0051. And you might say, well, why does a bigger sample give you a smaller deviation? If you do samples of 600 and you do lots of them, they'll look like that, right? And right in the middle, 0.5. If you increase your sample size, do you see how it gets less variable? Doesn't that really mean more accurate? So if you think standard deviation in the context of this question is telling you how spread out you're likely to be if you pick a sample. For big sample sizes, aren't you going to probably be dead close to the middle most of the time? And if it's a smaller sample, if I did a sample of 10 people, can you imagine that the distribution would be, I could get 0, couldn't I? And I could get everybody liking it, right? But if I asked 1 million people, can you imagine that the sample would look something like this? We'll assume that the right answer was a half. Can you see there's less variation the bigger the sample? And variation means essentially error. That's why it's sometimes called the standard error, right? It's how much error would you expect in your sample, right? Based on a particular sample size. So say your last name and bye-bye.